Hello, everyone. This is Eric back again, and I am doing furnace cleaning, maintenance, troubleshooting. And on this call right here, you'll see where I'm actually just going to be doing the cleaning. The customer is selling the house. So I started by cleaning the outside of the panels. This is a Goodman furnace. I believe this furnace was about 14 years old, and they just wanted somebody to come by and actually certify that the furnace and AC system was working. And so, I went through and started doing my cleaning. I like to get everything as clean as possible and check all the components. Started by taking this top cover off. This is where the inducer motor and the burners and everything that adds heat to the home is. Okay. This lower bottom panel has the blower compartment. This is what moves the air throughout the house to either add heat or remove heat. So you are using your blower motor throughout the year, you know, 365 days, depending on how often you use it. So, we're going to go through and, I got my little magnetic tray from Harbor Freight to keep all the screws in one section. I have a magnetic holder. I like to test the furnace out first to make sure that it does heat before I start taking everything apart. It's nothing worse than taking the whole system apart, putting it back together, then finding out that it does not actually work. So it's like the first little initial test that I do. You can see right here the igniter is glowing. So that means that the inducer motor already kicked on, the pressure switch is closed, the igniter glows, and then the flames turn on. Okay. After the flames turn on, the flame sensor senses the flame, then it kicks the blur on. So it's good. I'm gonna get my little headlamp on here. It's a very good thing to have when you're working on the furnace and basements and stuff like that. Sometimes you don't have a lot of light, so it's good to have some additional light to actually, be able to work and see where all the screws are. So I'm like, okay, give them the thumbs up. It actually works. So now I'm going to take my magnetic holder off, and now I'm going to kill power at the disconnect going to the furnace, the 120 volt circuit. So that way when I'm working on it, I don't bump that door switch and cut power on and blow a fuse or trip a breaker. So I normally start with the flame sensor, the igniter, those two components on the furnace. They're usually held in with, I think it's a 1/4 inch uh, nut or screw, I guess you want to call it. So I have like a little short stubby Klein little socket screwdriver, or I'll use that's the igniter right there. You see on the right side of the middle, there's like a little whiteness there, and that's where it will eventually burn out and it will not complete the circuit. So that igniter does look terrible, but it is showing some wear. I'd probably say it's about 50% used up. And I'm actually using a ratcheting wrench to take it off because it's easy to get up in those small little areas and stuff like that. You get them on Amazon, probably like $10 or so. It's just something that I've learned as I'm working on it. And this is the flame sensor here. This one's showing some wear. There is some black soot here and there, but it's not very covered in it. So it looks like that's in pretty decent shape. You can hit that subscribe button. You want to see me working on furnaces. This is more of a car channel. But this is where it kind of landed, in a sense. So I'm going to get you in a little bit closer here. And, I'm checking the safeties, the pressure switch, the vacuum line, all the electrical connections, make sure they're nice and tight, nothing is loose. I want to make sure that when it's running this winter that nothing just, causes a breakdown in a sense. That way it keeps the system running throughout the winter, because it does get about, 0 degrees, or it gets kind of cold here. So, the client will need to have a good furnace working. So now I'm here looking at this blower housing and the circuit board down there, and gonna go ahead and pull that out. This furnace, from what I remember, did have quite a bit of dirt and debris inside of it, and you'll be able to see it once I pull that blower wheel out, and you get some access to the actual secondary heat exchanger. This is a high efficiency furnace, so it's more of like a 95% efficiency furnace versus an 80%er. So this one has a secondary heat exchanger that condensates water and stuff like that. And the thing about it is that you want to make sure that you're keeping these furnaces filtered. Like, you got to change the filter, make sure they're clean. They're going to work a lot better when they're cleaner. If they get any amount of dirt and debris, then basically they'll overheat, or they could cause your AC to freeze. So I'm taking these wires off for the blower motor. Those are the different speed taps. Looks like that one may be a 4-speed blower motor. And then if I remember correctly, that's probably the capacitor wiring there. So that's a PSC blower motor. That's a permanent split capacitor mower. It's an older style. It needs a start run capacitor to operate. They do have newer blower motors that they're like an X13 or 2.13. That has 8 speeds or 16 speeds. It's a more of a variable speed motor, so you can match the airflow that you need for your system. So that's me taking the safety off. It had a safety in case it gets too hot down where the blower housing is. And right here I'm taking the bracket off for the circuit board. It is attached. It's got 2 screws on top and 1 screw on the side. And go ahead and get that bracket out of the way. So it is somewhat of a procedure, working on furnaces. So you have to be, it does take a little bit of time, but you just got to be conscientious of when you take apart. So a lot of times when taking all these screws apart, if it gets to be a lot, different ones, I'll even put the screw back in the same hole that it came out of, so I remember where it is, especially if I gotta take the whole furnace apart. Let's say I gotta get to the bottom of the evaporator coil that's sitting on top of the furnace, and I need to clean that. I'm definitely gonna be putting all the screws back in place. But for the most part, a lot of the screws are, I think they're like a 5/16 size. So you can basically just use I use like a nut driver or a little ratcheting wrench to get all that off. Right here I have a bungee cord, a little miniature bungee cord, so I don't have to take all the wires off the circuit board, and I can just basically just like tie it up and get out of the way so I could pull that whole blower motor out. So that's where you see where I'm about to go ahead and pull this out, and you can kind of see some of the dirt and debris that's on that very topness of it, and you'll see it on the motor. And when dirt and debris gets on to these major components like this blower motor, it can cause the seal. It's a seal motor, and basically it has a certain amount of oil in it, and whenever that seal breaks and it starts leaking oil, then it has a lot of shaft play, and then you have a potential for a breakdown. You can see how much dirt and debris is on that motor. I mean, it was caked on there. And just to think about, if it's running constantly, it's going to be running hotter because it can't breathe. The air cannot get to it where it needs to cool it off. So it's going to run hotter. And it runs too hot, and then it's going to have a potential for a breakdown. So I'm just taking pictures. I'm going to put in my report for the client so they can actually see it. The condition of that motor, that condition of it, just seeing that right there, it tells us that it is leaking oil, and you know it does have shaft play. So I'm taking my shop vac out. I'm blowing all that dirt and debris off of the circuit board and out of the burners. Sometimes I will take the whole burner cabinet out and clean it by hand, but in this sense I felt that it was okay just to blow the air out of it. And I find that having a shop vac does a really good job in the sense to do this, you know. So I did that, and then I went ahead and turned the shop vac in the opposite direction to actually, I believe, start sucking the dirt off that motor, you know, once I start getting it all out. Yeah, but during this whole process, we're taking pictures and making sure that, you know, everything, seeing what the condition of the system is, because this is my first time being there, and I've never seen this system. I don't know how well it operates and all that. And, you know, with it being the time of the year, you know, people not really using it that much, you know, the furnace or the AC, so we're kind of in between. So, like, you know, it's really hard to determine, you know, how good it's going to work during a 100-degree day or a 0-degree day, you know what I mean? And unless you're really there, this is probably like 70 degrees outside. All right, so see, yeah, you want to hit that like button. So you see all the dirt and debris on there, and yeah, I'm just moving some of the components out of the way so I don't actually break them in a sense. So now I'm going to get my crescent wrench and going to break that set screw loose that holds the motor shaft to the blower wheel, and always kind of put it a certain way, and I kind of hit it with my hand to break it loose, because I've had my hand in there and just turn it and you hit your hand on the wheel, and then you're bleeding, or you know your hand is hurting from hitting metal. So, you know, try not to do that. So once I get it loose and I know the wheel is actually going to come loose, then I take all the screws off for that mount the motor to the housing. And sometimes those are more like a 3/8 or 7/16, I believe. So try to get you in a little closer here so you can see what's going on. And basically I have a Klein screwdriver that has, you know, basically, you know, 6 different sizes that, I mean, with this one screwdriver you can basically take that whole furnace apart by hand. Yeah, but it's good to have a drill too, an impact drill, to do what you need to do. All right, well, there's 3/8 inch bolts that's actually holding that PSC permanent split capacitor motor in place. And basically it's a bracket that's actually welded onto these factory motors. So if you were going to replace this motor with one that's a universal motor or something that you buy online, you actually have to make sure that you get what's called a 3-arm bracket. So it would be the motor, the bracket, and then you want to replace the capacitor at the same time. So right now I'm just pulling it out, take a look at it, and you know, I check the shaft, see how much play it has in it. If it has a lot of play in it, you know, and it's leaking oil, that motor needs to be replaced, you know. You know, you keep letting it stay in there, but it's best to go ahead and replace it to give you that peace of mind that, you know, the furnace will work during the winter, or the AC will work during the summertime, you know, because this motor is always moving air throughout the system. So right now it's taking that shop vac and get all the dirt and debris off of it as much as possible. The client was not there at the time to, you know, prove any kind of recommendations, anything like that. I was just there just to do a cleaning and check. So that's the service that I'm providing here, you know, getting everything as clean as possible, putting everything to report. And then I'm gonna call the customer and let them know exactly what's going on with the condition of the furnace that they got, because they were selling the home. So this is the bottom portion of the cabinet of the furnace. You know, this is where the blower housing is, and you know, you see the air filter to the left. And I have a, basically a condensing coil, foam and rinse and spray. And this works great just to spray it all in there. It breaks up all that dirt and debris and grime. Just let it sit for like a minute, and then we use white rags to basically wipe it clean. And I mean, it comes like a brand new system in a sense, you know. Because the cleaner that you keep these systems, the better they run, the more efficient they run. It's better clean air for you in your house, you know. So all the way around, you need to get the system cleaned. You know, we recommend it every year. Depending on the type of filtration system that you have, the better filtration system you have, the better it'll catch all the dirt and debris out of it. So, you know, you may be able to extend that cleaning, but, you know, definitely want to get it checked every year, especially with the age of it. So you can see how clean it's getting. You know, that Goodman furnace is coming like a brand new furnace in a sense, you know, because we want to give the new homeowner, you know, the best life left in this furnace, since they decided they're not going to replace it. They just want to get it, you know, cleaned and checked. And basically I was providing a report to the new homeowner, you know, because I believe they actually had the sale, the purchase of the home was going through. They're about to close in like probably like a few days or something like that, you know. So, you know, some people do decide on just getting new equipment, but some people decide it's best to put the best foot forward and get it cleaned and checked, and, you know, do any kind of maintenance that it may need to get them through, you know, a few years, and after that they can do what they wish with their equipment. So this is a high efficiency furnace, and, you know, right now I'm just checking to get all that dirt and debris out of it. I believe the filter was in decent enough shape that can be left in there, but you can see how much was on that rag. I mean, just years and years of stuff inside of it. You know, in a sense, you know. So just going through, getting every bottom panel, side panel, the corners, you know, getting everything as close to brand new as possible. And that's the type of service that we provide, you know. For, we call it a tune-up, and you know, it's normally valued at like $255, and, you know, we're running a special for $39 to try us out, you know. So it's a good deal, you know. So you know, I'm going to take a look eventually at the secondary heat exchanger that's on this furnace, and you know, we'll go in there. But this is that motor, you know. It's going to go ahead and wipe it clean. You know, probably needed to recommend replacing in the future. I think this one was still in good enough condition to just get it clean and, you know, put it back in. It wasn't making any noise, anything like that. When all the oil leaks out and it has a lot of shaft play, then they'll start making noise when they're running, and eventually they will seize up. So you may not actually hear it, but you'll, you know, once you do start hearing it, it's time to replace that motor. But from what I remember on this one was, I think we caught it in good enough shape before all that dirt and debris just kind of caked it over, because, you know, what it would have suffocated it, and basically it would have overheated that motor. Then the motor would have leaked oil, and then it would have seized up, and then, you know, the thing about it would have ended up burning out the circuit board too, because now, you know, it's working harder than it should. It's using more power, then the circuit board starts burning out too. So it's kind of like an orchestra in a sense. Like, once you have one thing that's out of, like, one instrument that's out of tune, then the whole, you know, event sounds bad. So you have to keep everything in good working condition. I believe that shaft had a little bit of wobbliness. Right here you can see that secondary heat exchanger on this high efficiency furnace. So you know, this may be a 95 to 96%. So all the gas that is being put into it, you know, this furnace may be losing, you know, 4 to 6, 7% of the energy put in. So we want to clean. That's why you want to have a good filter. You can see that you know, that secondary heat exchanger had a lot of dirt and debris in it. So you'll see here in a little bit, I'll take a brush, clean it out, and then I'll take the foam spray and clean it too. Underneath this, this exhaust motor, this inducer motor, just wiping it clean. But there was a spot where the collector box gasket was leaking, and the gasket from the collector box to the actual inducer motor, it's like sometimes a rubber O-ring, or it could be a foam gasket, and that needed to be replaced on that. So that's what I was going to talk to you about the customer. So this part, I've actually taken the blower housing out with the blower wheel and taking it outside, and just coating it down with that foam rinse spray, and that's going to break up all that dirt and debris that's on it. And you'd be surprised, once that blower wheel gets, they say, a 20th of an inch of dirt on the wheel, then it will actually throw the airflow off, it'll throw the balance of the wheel off, and it'll make the system actually work harder, start using more electricity. So just by having this simple clean and check done will make the system last longer and will prevent breakdowns in the future. So, going through every nook and cranny, going to spray every side of it, and then I'll take my brush and start brushing all the dirt, and we'll rinse it here in a little bit. But, we're also checking to make sure that this blower housing is still in good condition, that it's not becoming loose. If it gets loose in any of the scenes where they're connected together, or any of these bolts that are holding it together, it will make noise when the furnace is running. And then you have to, it's just best just to replace the whole housing and the wheel. And if the motor is looking like it needs to be, you recommend it replacing too. Just do all the parts at one time. Basically put in the whole bottom end of the furnace, so that way it works, it doesn't make noise. And because just having a wheel that's off, or a blower motor shaft that's not balanced right, will throw the whole system off. And you'd be surprised. So right here, this is a condensate brush, but I use it for the furnace to get in there and just knock a lot of that dust and debris off of it. And that would cause issue. If they kept running it in that condition, that wheel would have thrown the motor off, and then yada yada yada. In a sense, same thing would happen. So after everything soaks for 5-10 minutes or so, just go through with a water hose, connect it up to the house, and I set the nozzle to the jet spray to get as much force of the water out, to basically get it clean. And you can see in the pictures or this video, where it actually becomes quite clean for the most part. If it's just normal dirt and debris, they come clean. If it's a motor that's been leaking oil for quite some time, those are harder to clean, because then all the dirt and debris sticks to oil, and the oil sticks to that blower housing. It's all over the wheel. It's just a mess at that point. So it takes like twice as long to clean it. So usually I let clients know that when we kind of just stop by the house at the beginning of the conversation, that depending on the condition of the system, it could take 1.5 to 2 hours or longer. It may even take 3 to actually get it as clean as possible. Because I'll take just about every component out besides the heat exchanger, in a sense, unless we just need to kind of verify the operation and condition of that too. But usually you can kind of see it, especially on the Goodman high efficiencies. I don't have a picture right here on it, but you will look at the burners, and you will see rust around the burners on the inside of the furnace. So now I'm going through, taking that white rag and getting everything clean as possible. And here's that secondary heat exchanger. So basically, this is a high efficiency furnace that has 2 heat exchangers. You have a primary that's above this secondary. The primary is like a car muffler system, in a sense, that the heat, heat it up, and then what it does, it goes through that primary heat exchanger. Then After it goes through that, it goes through a secondary heat exchanger, which are like smaller tubes. And when it goes through that secondary heat exchanger, it actually starts condensating water. So, these furnaces actually have a drain line that come off to the side, and you have to make sure that it has a trap and everything's drained properly. So, the secondary heat exchanger is kind of like a little small radiator in the sense that you can see on the bottom. Need to make sure that you're very careful with the fins of it. That's why I'm taking this condensate brush and just being very easy and gentle on them, not bending any of the fins. I do not want to restrict airflow that's going into the system. I want to make sure that everything stays in factory specifications as much as possible. So that's why I take my time with that brush and get as much of the build up off as possible. In a sense, I guess I could have took that shop vac, but I find the brush works well. And sometimes I get tired, so I skip parts. So now we got the blower housing and the wheel are all clean. The motor has been cleaned by hand, and I've taken my shop vac and blown all the dust out. So now I'm actually in the process of reassembling this lower portion of the furnace, and I use all hand tools. I treat the equipment like it's a Ferrari or Lamborghini. That's something that's built by hand. I do not want to use power tools that may actually strip out bolts, anything like that, because then you strip out a bolt, then something gets loose, then something makes a noise, then something gets off balance, then it just throws the whole system off in place. So it's best to take your time and go through and take everything apart by hand and put everything back together by hand. So I normally don't use power tools unless it's just something that I just want to get in and out, or something just for special occasions in a sense. So, now taking that motor, I've cleaned the shaft hole out of the blower wheel with a wire brush and taking these 3/8 inch bolts and putting it back on the housing. And whenever you do put the blower motor back on, you got to make sure that the wiring for the blower motor is in the right direction, because it has to come towards the front of the furnace. If the wiring is going towards the back, then it may not reach and they may not be long enough. Then you'll find out by the time you actually slide it all together, put everything back together, that the wires are not long enough. Then you have to take everything back apart. So I find it best, you can take a Sharpie and you can see how the wires are coming towards the front of that housing. Whenever you take it apart, just take a Sharpie and actually mark a direction on the blower housing where the wires were located, so you can put it back in the same exact spot that it was in from the factory. So now that the motor's been mounted to the wheel, making sure that I'm lining up the actual wheel inside the housing has to be centered in there. That way when it's actually running and spinning and moving air, that it's not going to hit the sides of that housing in a sense. And you have a set screw, so basically you can take a crescent wrench and tighten up that set screw, so that way it's not going to come loose. And I also do a spin test. These factory motors are only set up to spin in one direction. You have to be careful if you are purchasing a universal blower motor. You can have a blower motor that can go in two directions, and you will find that it will have additional wiring onto that blower motor, different colors, like an orange color and maybe a red color, and there'll be shorter wires, and they'll be basically tapped together to themselves, and you can make the rotation of that blower motor go in a different direction. So if you are putting in a new motor, please make sure that the motor will rotate in the right direction to move air throughout the house, because if it goes in the opposite direction, the system will not work. Especially on a dual shaft. You always need to actually test it out with 120 volts, just basically send power to it and actually make sure it moves air to the top of the furnace and not going to the bottom. So right now I'm sliding everything back in, and there's two screws that go to the top of that bracket that mount into the furnace. And I want to make sure that when you're sliding in that you hit the side brackets. Sometimes it's a full bracket that may be 12 to 18 inches long. Sometimes that bracket may be in 3 different pieces, and if you go under one piece, then that housing and motor will not be installed properly. Then it will make noise. So just take your time. This is where having a good headlamp will actually, you can look at it when you slide in, and just make sure you take your bolts and tighten them up by hand good. And make sure that wiring is coming towards the front of the furnace. Once you get everything nice and tight, then you can start mounting the circuit board back on that housing. Some circuit boards will actually mount to the furnace, so it all depends. And you should always have a picture or diagram where all the wires were connected. Normally you have black going to cool, blue goes to heat, red and orange would be, or yellow could be a spare. That would go on spare or M1 and M2. And you always have a white neutral wire that provides 120 volts. And then you should have 2 brown wires that go to your blower motor capacitor in a sense. So sometimes if it's at the market, may be brown, and the other one may be brown and white. So it depends on your system. But you need to make sure that you set up the speed tap wire correctly to how it was before, or you need to match it to the furnace. If it is a 3rd horsepower motor, you need to set it to a 3rd horsepower. It can go to a 1/2 horsepower. It can go down to lower. So it may not be always black for cool or blue for heat. It may be red or orange or something like that. So, all right, we went ahead and got everything reassembled, and I always like to do a final test of the system. I take jump wire from R terminal and W terminal, and I make sure my door switch is in, fire up the furnace, make sure it goes through sequence operation before